let's kind of start talking through. So like I was saying yesterday, I think this first one here, it's something that you may or may not have been exposed to, and even if you were exposed to it in algebra, you might not remember it off the top of your head. Like when I taught algebra, we taught it, but who knows if you got it or not when you guys took algebra. So basically what it is, so difference of squares, when they're talking about squares, they're just meaning like things to the power of 2, and then difference is just subtract. So what happens is if you have something like this that's two square numbers or variables or whatever that are being subtracted, it's always going to follow a pattern where it's always whatever the first base is here, so like the A, minus the second base B, times, and then those same bases there with a plus sign in between. So one of them's minus and one of them's plus. Why that works is if you do like the FOIL out there, your middle things for like the outside and inside, O and I, are going to end up being like a positive BA and a negative BA. If you take a positive BA and a negative BA and add those together, those are always going to cancel. So the middles always cancel out, and that's why it ends up just with two things there. Okay, so that will always work if it's difference of squares. You can always follow this pattern where you just take one of the things, the other thing, put a subtract in, put an add in, and then that's factored. Like I said, that may or may not have been something you know. If you didn't know, I wrote it down there so you got it. Now, the new ones to us, or even that one might have been new, is sum and differences of cubes. We don't have a sum one for squares. It doesn't work for squares, just for the cubes ones. But we've got sum and difference for the cubes, and they've just got it written out there as the theorem, or it's just kind of these here. Basically, it's kind of a similar concept where you've got, two different numbers here as the bases. The powers are both 3's here, so if you've got adding and you've got powers of 3, the factored form of that is always going to be like parentheses, whatever the one number is for the base plus the other number. Then it's always going to be whatever your first one was squared minus whatever your two things are multiplied together. And then the back one is always plus whatever your last thing was squared. And then the other one with differences, so difference of cubes, follows a similar pattern, except for, it's subtract there, so it's subtract here, and then both of those are plus. I'm not going to make you memorize those. The guy in the video I was watching said, make sure you memorize this. I'm not going to make you do that, but how he said that is like a trick to remembering how to do that. He said it follows like SOAP. So what the SOAP stands for, like if this is add, the first sign always stays the same here. So what they go with the SOAP stuff, and again, you don't have to memorize this, but it's always the same sign for that first parentheses group. The next symbol that you have there is always opposite. So here it was plus and it switches to minus. Here it was minus and it switches to plus. So the next sign is always the opposite sign. And then the AP actually kind of goes together. It stands for always positive. And that just means your last symbol there is always positive. Again, I'm not going to make you memorize that because I'm really nice, right? The guy on the video was making his kids memorize it, and, that was the way to memorize it. But like I said, you don't need to know that. But, like, when I was doing these, instead of, like, looking back at my notes every time, it was kind of nice to, just remember that off the top of my head. But, again, you can just look at your notes. So then once we get it to that point, sometimes you have to factor a little bit further, kind of like we had yesterday where, we could pull something out, but then we were left with like a trinomial or something with like 3 things, and then we could factor a little bit further. If you have to do that, you can use quadratic formula just like we were doing yesterday to keep factoring further. Okay, let's look at some examples before we look at that crazy one there. Okay, so grab your packets out, and we're going to look at the first one here. So it wants us to find the sixth roots of 729, okay? So basically what they're asking us here is what 6 numbers to the power of 6 are 729, okay? So what I would do when I'm doing 6th root, the opposite of that would just be like to the power of 6. So this is the same as something where it would be like x to the 6th is equal to 729. And we just are going to try to figure out what those x values that would be in there, and there should be 6 of them, okay, because it says find the six roots, so we should have 6 different answers here, okay. What I'm going to do is I'm going to take this and I'm going to get it equal to 0 so I can do my factoring stuff like we've been doing previous days. So I'm going to take it, I'm going to subtract 729 from each side and make this x to the 6th minus 729. is equal to 0. And again, I just do it like that, so that way when it's equal to 0, we can do our factoring stuff and find our zeros like we were doing before. So then now what we're going to do is we're going to mix in kind of that difference of squares, difference of cubes stuff. So here, what I'm going to do is I'm going to go with difference of squares first. So what I need to do here, so if I look at this and I look at this, they're not currently squares, so they're not currently like to the power of 2, but I'm going to do something to make them squares, okay? So what I'm going to do, if this is x to the 6, that's the same as x to the 3rd squared, okay? So my goal was to get this to squared because I want to try, I'm going to do difference of squares here is what I'm going to try to do. So I need to get it to a square. Then I'm going to do the same thing with my 729 to figure out like what that would be, like something squared. I just take the square root of 729. So if I just did that on my calculator, square root of 729, it's 27. So then that would be minus 27 squared. And like I said, the reason I did that is because now I've got something to the power of 2 and something to the power of 2, and it's subtract in between. So now I can use this difference of squares thing that we wrote down before, okay? So what I'm going to do, that difference of squares, you've got two parentheses groups here. You take one of the terms from each of these, so like the x to the 3rd and the 27. And x to the 3rd and 27. Then one of your symbols is plus and one of your symbols is minus. I'm going to go minus and then plus. It doesn't matter the order on that. I just do it like that. Okay, so now what gets kind of annoying with this is we can actually keep factoring here because now we're to the point where we got to a power to 3. 27 you can also make to a power of 3. Does anyone know what number to the power of 3 is 27? It'd be 3, because 3 times 3, 9 times another 3 would be 27. So what we can do is we can turn these into difference of cubes and sum of cubes. So what I'm going to do is I'm going to switch this to x to the 3rd minus 3 to the 3rd. And x to the 3rd plus 3 to the 3rd. And those would be, the one with the plus would be sum of cubes that you're looking at, because those are both cube numbers. And then the other one would be difference of cubes that you're looking at. So then what you got to do is now you use the other formulas that we wrote down there, the one that's the sum of cubes and the difference of cubes. So here, if this is difference of cubes, we're going to go parentheses. It's always same symbol for our first one here. So if that was subtract, it'd be x minus y, parentheses. Then it's always our first term here. So our first term there would be like the x. So it'd be x squared, because it's just that number, the x, or letter in that case. And then it's always opposite symbol, so if that was subtract, it would be plus. And then you pull one thing from here and one thing from here, so it would be the x times the 3, which would be 3x. And then your back one is always plus, and it's whatever your back symbol or your back number is there, squared. So you would take that 3 and you would square it, and you would get 9. Follow me so far-ish? Like I said, we're getting to some crazy stuff. This is lots, okay? So that was that one where it's difference of cubes. Now we're going to do the other one, which is sum of cubes. So we're going to break this guy down into the sum of cubes. So that one is our one, so we always keep it same sign for the first one. So if it was plus here, it'll be x plus y, parentheses. And then we take our first letter there, which is the x. So x squared, always opposite sign next, so the minus. One thing from here, one thing from here, so that would be x and 3, so 3x. And then the back one is always our last thing squared, so the 3 squared would be 9. And believe it or not, we're still not done, because we don't have our zeros yet. So what sucks here then is these, so this one and this one are good. These two, though, can be factored even further. Okay, so this is where I would use the quadratic, and that's kind of what this bullet point's talking about here. If we need to factor completely, which we do to find all of these things here, then we're going to take whatever that trinomial is, and we're going to use that quadratic like we were doing from the other day. So what I'm going to do here is I'm going to take this one and do quadratic on it, and I'm also going to do this one and do quadratic on it. The nice thing, though, is these are very similar to each other, so I'll show you how to kind of speed that up. So I'm just going to draw a line here so I know it's kind of separate from that stuff. I'm going to do my quadratic off to the side here. I'm going to do the one that's the x squared plus 3x plus 9 here first. So first thing with quadratic, we identify our a, our b, and our c. So our a is always what's with the x squared, so that'd be a 1. B is always the middle one, which is the 3. And then c is our constant, which would be the 9. And then we just go into quadratic formula, so it would be x is equal to always the opposite of our b, so negative 3, plus or minus square root of that b value squared, so 3 squared, minus 4 times our a value, which is 1, times our c value, which is 9, over 2 times our a value, which is 1. Then we just work our way through there and simplify that, so it'd be like negative 3 plus or minus. Under our square root there, 3 squared is 9. And then minus our 4 times 1, 4 times 9 would be 36. And then our bottom would simplify to 2. And then, of course, sucky thing here is now we've got a negative under that square root, because when we do 9 minus 36, we're going to get a negative. So we'll have negative 3 plus or minus square root of negative 27 over 2. Then we remember when we have that negative under the square root, we pull that negative out and swap it out for the I. So this would be the same as like negative 3 plus or minus square root of 27, and then the I at the back over 2. And then classic situation where they give us a shitty problem here. Square root of 27 can go down further. So you pull the cube or you pull the square root out of that. The biggest square root that can come, or the biggest perfect square that can come out of that would be 9. So it'd be like square root of 9, square root of 3. So that's the same as 3 square root of 3. Then we can just take that and swap it into that problem there. So we'd have negative 3 plus or minus 3 square roots of 3 with that I at the back still there over 2. So that would be 2 of our solutions, right? Because we would have one here that's the positive version, one here that's the negative version. Now the nice thing here is if I do this whole thing out here, I could go through and do quadratic again, but if this one and this one are very similar and the only thing that switches is subtraction, the only thing that would affect here is that 3. So anywhere I put in a 3, it would just end up being the opposite sign. If I go in here and I square like a negative 3, don't I still get 9 there? I should, so all that stuff's going to stay the same. The only thing that's going to switch for this one here is where you have the opposite sign here, so it'll just switch to a positive 3. So for this other one here, I'm just going to draw a line, where it's the x squared minus 3x plus 9. Like I said, the only thing that's changing is that negative there, so our solution is going to be the same, except for that front symbol is just going to switch. And that just conveniently works out for us. So in this one, it's going to be a positive 3 plus or minus 3 squared roots of 3 with the I over 2, and that saves us a load of time so we don't have to do quadratic formula again. Okay, so now we have all our answers. Let's just write them all out so we can circle them and know that we're done. Okay, so zoom out here a little bit. So here, oh, who didn't stop me when I was writing this wrong? All right, I made an error. Go back and switch these to 3s. It's a lot for me too. Trust me. When you're doing it and you're looking at me like I'm crazy, I'm thinking I'm crazy when I'm doing it too. So I know, I get it. So yeah, switch those to 3s. Sorry, I messed up on that. And the rest of it looks to be good. So it's just those 2 I messed up on. So then to get our actual like 6 true numbers here for our answers with this one, so these are all going to be like x is equal to. With this one, we're looking for what would make this chunk a 0, so we know it's always like opposite sign when it's like this. So like here, our x that we could go in there would just be a regular 3. Coming off of this one, these are the ones where we did that quadratic formula out, so that's these values here. So it would be like one of them is like negative 3 plus 3 square roots of 3 I over 2. And then the other one coming off of that one would be the same exact thing except for a minus in between. So negative 3 minus 3 square roots of 3 with the I over 2. Coming off of this one Here, to make that chunk equal to 0, it would have to be a negative 3, because negative 3 plus 3 would be 0, so that one is just a regular negative 3. And then coming off of this last one here, this is the one that we kind of cheated it. Not really cheated it, but we used our logic to kind of speed it up there, where it's the same exact thing except for just a positive 3 in there instead. So coming off of that would be a positive 3 plus 3 squared roots of 3I over 2. And then the same thing, positive 3 minus 3 squared roots of 3I over 2.
Students and teachers, just a heads up, that is a citywide test. So apologize for the sirens, but that is a test. Thanks.
I was really concerned there was a tornado blowing through. Jesus. Okay, anyways, now we can breathe a sigh of relief because that problem's done. That's a lot. That's a lot. I can tell by your faces that that's a lot. That's a lot for me too. Okay, but those would be our 6 roots. Again, when I put it on the test, it's going to be stuff like this where you got to break it down, but I'm not going to put crazy ones where you got to do all this extra business and all this stuff here, okay? So as long as you understand the general concepts, and we'll practice as we go, you should be okay. All right, let's try another one here. Okay, so this one, not as long as that last one. That last one's a whole lot. So this next one here, they want us to factor x to the third plus 10 over the set of polynomials with real coefficients. So that just means they want us to factor it, basically. So we're going to use the one that is the sum of cubes, because we got a cube here and we got a sum. 10 is not a perfect cube, so like a perfect cube would be like 8, because that would be like 2 times 2 times 2. 10 doesn't work for that, but I'm going to show you how to work around that. So here we're going to use sum of cubes for our thing. So we've got, and sum of cubes, if you want to write it here so you got it to reference to, is the one where it's like that, and then it's like the x plus y, and then the x squared minus xy plus y squared. That's the one we're looking at. So what we're going to do is we're just going to take this here, the x to the third plus 10, and we're going to turn that into this setup right here. Okay, so like making reference to that equation, the x is just going to stand for x when we plug it into here. The 10 is going to stand for the y, but when we do it, it has to be whatever that value is cubed. Like I said, 10 doesn't, there's not a nice number for 10 that's like the cube root of it. So what you do is you just leave it as the cube root of 10, because that's just saying if you took whatever that decimal number is, times itself 3 times, it would kick you back to 10. Okay, so it's just kind of like cube rooting something. That's the same as, you don't have to write this, but it's the same as something like that too if you needed to put it in your calculator for some reason for something, but that's what that is. Okay, so then what we're going to do is we're just going to fill these things into those spots. So we're going to go parentheses here. Again, it's always the same sign when we start here. So if that was plus, it'd be plus there. Our x is going to be the x still. Our y representation here is going to be that cube root of 10. And then we go to that back part there. And again, it's always whatever our first value was there squared. So in our case, it's still just the x. So x squared minus, because it's always opposite sign next. And then it's whatever our x was times whatever our y was. So it'll be x times this or the cube root of 10. So it would be like cube root of 10 with the x plus, and then this is where it gets kind of gross. And again, like if I'm putting this on the test, I'm not doing it where you have to put the cube root shit. I'm just going to do it where it's like 8 and it comes out nice. You know what I mean? So like here you would do cube root of 10, and it's always that value squared. Now what gets a little bit messy with this one is you can actually simplify this a little bit. So you could take and square the thing that's under that cubed root. So 10 squared would be like 100. So this here is the same as like the cubed root of 100, and then the rest of the stuff would like stay the same. Again, when I put this on the test and stuff, I'm going to put it on there, but it's not going to be with this gross numbers and stuff. It would be like an 8 or something that's going to come out nice, okay? And if it was like an 8, it would just be like 2 into those spots, okay? But that would be as far as you can go with that one. Okay. Okay, next one. All right, we want to factor 973 by knowing that 973 is the same as 10 to the third minus 10 to the, or 3 to the third. Okay, so similar concept here. So we got cubes again, but this time it's subtracting between. So this time we're going to use difference of cubes. for our setup of this guy. So the difference of cubes ones, again, you don't have to write this, but if you want to, you can, is like x to the third minus y to the third. And then that's going to kick out x minus y. And then it's always the x squared, and then it's opposite sign, so plus your first thing times your second thing, so x times y, always plus at the back, and then your last thing squared. So in this case, if we're trying to figure out, okay, what's my x, what's my y and y in this case, to put into like this little formula here, my x would be like the 10, and my y would be like the 3, so I'm going to go 10 and 3 for those. Then I'm just going to take those guys, and I'm just going to stick them in the spots for the x and the y. So here I've got 10 to the third minus 3 to the third is equal to, for my x and my y, I'm just putting that 10 and that 3 in there, because those are to the power of 3. So 10 minus 3. And then for the back part there, I've got x squared, my x is 10, so 10 squared plus, and then I'll have x times y. So x times y we would know is like 10 times 3 plus, and then my back thing is my y squared. My y in this instance is going to be the 3, so 3 squared. Then in this case, what you can do, because it is all numbers and not just like, you know, variables and that kind of thing, you can actually just kind of simplify this down here. So like if we did here 10 minus 3, that'd be 7. Inside our next parentheses group there, 100, or 10 squared would be 100. 10 times 3 would be 30. And then the back one, 3 squared would be 9. And if I add all those guys together, 130 and 9 would be 139. And then it just wants us to factor it, so you would just leave it like that, because if you multiply it out, it's just going to get you back to that original number. So you don't want to get back to that original number, you just want to leave it like that. That's a little bit different style when they have just regular numbers in there. Okay, then we got 29. Okay, well let's at least talk about this next one. I don't know if we'll finish or not, but we'll see. Okay, so next one here, sums and differences of odd powers theorem. So the cubed one we got down, we got that little, you know, setup we can use. If it's another odd power, like, you know, 5, 7, 9, whatever, you can use these little, you know, equations or formulas here. They seem very confusing, but really all it is you're just taking, so like here if it's, you know, x to the nth and y to the nth, and those n's are odd powers, you're just taking whatever those bases are. You just, if it's add 1, you add it. If it's subtract, you subtract. Then what's happening here is you're taking like the x's and y's or whatever you have for your, you know, letters, and you're writing it out a whole bunch of times here, but it's going to follow a pattern where whatever your first one is, it's always 1 less than whatever your original power was, and then each time it's going to get 1 smaller, and then your opposite one, whatever the back one is, each time that's going to get 1 bigger. Okay, I'm going to show you an example here that's going to kind of help you out on that. Notice and be very careful on this. This top one, the symbols are alternating from positive to negative, so I would write a little note there that they're alternating. Positive and negative, so just be careful on that if you've got a situation like that. The bottom one, though, is always positive or always plus. Okay, so just be careful, because if it's that top one with a plus originally, the symbols alternate, which can kind of mess people up. And then if it's the other one, then it's just always add. Okay, so let's take a look at one like that then. So that would be similar to like number 4 here. Okay, so we can see here it's not cubed, so we can't use the cube stuff, but it does have an odd power, so we can use our odd power stuff. This one has the plus sign in between, so we're going to have to use the top one where we alternate between the plus and the minus. So what you're going to do here, you got a to the 11th plus b to the 11th is equal to, you always just pull one out completely, so an a plus a b out completely. Then what we're going to do is we're going to start doing a pattern here, where it's always, our next one here is always whatever this first letter is, and then your power is minus 1. So it's going to be a, and then there, if that power is 11, it's always 1 less than that, so 10. And we're not going to do any of the b's there. And then our first symbol from the formula is subtract. Then we're going to go a again, but now we're going to drop down a power, so now it's going to be to the 9th. And then you're going to throw the b in there, and the b is going to be to the first, because that's the first b. It's kind of like you had 0 b's here, 1 b, and then you're just going to kind of keep gaining on that. The power should always add to 10, okay? It should always add to 1 less than what this original was. So then you just keep working your way down there. Again, the symbol's alternating, so we're going to switch to plus. Then it's going to be the a to the 8th, because that one's dropping, and the b is gaining 1, so 2, and again, 8 and 2 makes 10. Alternate symbols there for subtract. A drops to 7, b goes up to 3. Alternate to plus. A drops to 6, b goes up to 4. Go to subtract. A goes up to 5, or goes down to 5. B goes up to 5. And then I'm gonna run out of room here, so I'm gonna drop it down below. I would alternate to plus. My A is gonna drop to 4. My B goes up to 6. Switch to minus. My A goes down to 3. B goes up to 7. Alternate to plus. A's to 2. B's to 8. Minus. A's to 1. B's to 9. And then your last one would be all of them being the B's, so plus B to the 10. And then once you get to that point where you've done all your A's out and you're down to like 0 of the A's, that's how you know you're done. Okay, and it's just always going to follow that pattern every single time where it just kind of drops down there or the other one's gaining. Okay? Okay, one more here and then we'll wrap this up. Okay, so last one here then, we're supposed to factor m to the 4th minus 81n to the 4th completely over a set of polynomials with real coefficients. So again, when it says that, that just means we're factoring. So this one, we're starting with m to the 4th minus 81n to the 4th. This one, to me, since it's even powers, I'm thinking we can probably do something with the squared. So I'm probably thinking we want to turn this into something with difference of squares. So I'm going to switch m to the 4th to m squared, and then square that, because that's the same as m to the 4th. And then I'm going to do the same with this other stuff here. So I'm going to take the square root of 81, which is 9. And then if I take here and switch this to n squared, and then square it out of there, that's the same, same formula there, or the same expression. And this turned it into difference of squares. Then from there, if that is difference of squares, what I can do for difference of squares, that's where you just take your two things and you put opposite symbols in, so one's subtract and one's add. And then you're just going to have an m squared and 9n squared. Then your other one would be m squared plus in the middle, 9n squared. This one can't go any further because it's plus, but this one here would also be difference of squares, kind of like we had there. So that one's also difference of squares. So that guy's going to stay the same, but here we could break this into our two groups, break it into m. And then this would switch to, because it's 9 here, we're square rooting that, so that would be 3 with the n. And here it would be the same thing except for plus, so m plus 3n. And then, like I said, there's nothing for us to do when it's addition, and it's two things like that, so you just have to leave that one as m squared plus 9n squared. And that would be as far as you could go on that one. Okay? It's a lot. I know it's a lot, okay? We'll see how it's going. We'll get the practice in that we need. Try the stuff, see how it goes. If it's not going well, like I said, we can hammer some stuff out if we need to, okay? I'm not going to throw you into the fire without at least getting a good understanding, okay?